So here we have a function given by x squared minus 2 divided by x squared plus root 2x minus 4. We have to find its limiting value when x approaches root 2. So let us begin by first doing a direct substitution for the values of x. So we have root 2 squared, which will give us 2, minus 2 in the numerator, divided by square root of root 2 squared will be 2, plus root 2 times root 2 will be 2, minus 4. So this gives us 0 over 0, which is an indeterminate form. So here x minus square root of 2 is a common factor in both the numerator and the denominator. So let us begin by first factorizing the numerator. So we have x squared minus 2, that can be rewritten as x whole squared minus, so 2 can be written as square root of 2 whole squared. So here we are going to apply the identity that a squared minus b squared is equals to a minus b times a plus b. So this gives us x minus square root of 2 multiplied to x plus square root of 2. Then we have to factor x squared plus square root of 2x minus 4 as well. So what we're going to do, we're going to perform a synthetic division here. We're going to divide x squared plus square root of 2x minus 4 by x squared minus 2. So what we do, we begin by first writing down the coefficients of the quadratic polynomial, starting with 1, then followed by root 2 and negative 4. So we are going to divide it by square root of 2. Now we draw a straight line and then bring the number 1, the first value, as it is. Now we are going to multiply 1 and root 2 and place it here. So 1 multiplied to square root of 2 is going to be square root of 2. Then we add down the column, so that gives us root 2 plus root 2 is going to be 2 root 2. Now we are going to multiply 2 root 2 to root 2. So 2 times 2, so that will give us a positive 4. Adding down the column was going to give us 0. So here we have a remainder of 0. So that means x minus root 2 is indeed a factor of the quadratic polynomial x squared plus square root of 2x minus 4. Now this number is going to be the factor of the quadratic polynomial. So 1 will be 1 multiplied to x plus the constant coefficient 2 root 2. So that means this will have the factor x minus square root of 2 multiplied to x plus 2 root 2. Now we're going to replace the limit value, the function, by its corresponding factor. So we have x minus root 2 multiplied to x plus root 2 divided by x minus root 2 times x plus 2 root 2. So we cancel out the common factor from both the numerator and the denominator. That leaves us with limit x going to square root of 2. So we have x plus square root of 2 divided by x plus 2 root 2. So we substitute for the value of x. So we have root 2 plus root 2 divided by root 2 plus 2 root 2. So that gives us 2 root 2 divided by 3 root 2. So the square root of 2 gets cancelled out. Then we have the limiting value of 2 over 3. So here we need to determine the limiting value of the given function when x approaches square root of 3. So the first step will be to substitute the value of x with root 3. So we have x squared, so that will be square root of 3 squared, which will give us 3 minus 3 in the numerator, divided by 3 plus 3 root 3 times root 3. So that is simply going to be 3 times 3, which is 9, minus 12. So we get an indeterminate form, which is 0 over 0. So that simply means that x minus the square root of 3 is a common factor in both the numerator and the denominator. So we begin by factorizing x squared minus 3. So this could be written as x squared minus square root of 3 whole square. And we go apply the formula, not the identity, that this is equivalent to x minus root 3 times x plus square root of 3. Now we go to the denominator given by x squared plus 3 root 3x minus 12. So we are going to perform a synthetic division here. So we first write down the coefficients of the quadratic polynomial. So we have 1, 3 root 3 and negative 12, and we are going to divide it by square root of 3. So now we bring down the value 1. Now we are going to multiply 1 with root 3 and write the value here. So we have root 3 and we're going to add down the column. So 3 root 3 plus square root of 3 is going to give us 4 root 3. Now 4 root 3 times root 3 is simply 4 times 3, which is 12. So adding down the column gives us 0. So that means this division is giving us the remainder of 0. So now we have 1 times x plus 4 root 3. So this is going to be the quotient. So we have x squared plus 3 root 3 minus 12. This can be written as the product of x minus root 3 times x plus 4 root 3. Now we're going to substitute these values back into our original function. So we have in the numerator now x minus root 3 times x plus square root of 3 divided by x minus square root of 3 multiplied by x plus 4 root 3. So we are going to cancel the common term, so that leaves us with limit x going to square root of 3. We have x plus square root of 3 divided by x plus 4 root 3. So we substitute for the value of x. So we have square root of 3 plus square root of 3 divided by square root of 3 plus 4 square root of 3, which is going to give us 2 times square root of 3 divided by 5 times square root of 3. So this root 3 gets cancelled out, so, and that leaves us with 2 by 5 or 2 over 5. So this is going to be the limiting value of the given function. So here we need to determine the limiting value of the given rational function when x approaches square root of 3. So let us begin by doing a direct substitution here. So we have square root of 3 raised to the power of 4 minus 9 divided by square root of 3 whole square plus 4 root 3 times root 3 minus 15. So we have square root of 3 multiplied to itself 4 times, so that is simply 9. So we have 9 minus 9 divided by 3 plus, so root 3 times root 3 is going to be 3, so we have 4 times 3, which is 12, minus 15. So that gives us an indeterminate form 0 over 0. That tells us that x minus square root of 3 is the common factor in both the numerator and the denominator. So now we begin by factorizing the numerator, which is x raised to the power of 4 minus 9. This can be written as x squared whole squared minus 3 squared. So we're going to use the identity that a squared minus b squared equals the product of a minus b and a plus b. So we have x squared minus 3 times x squared plus 3. Now x squared minus 3 can be rewritten as x squared minus square root of 3 whole squared multiplied to x squared plus 3. So that gives us x minus square root of 3 times x plus the square root of 3 multiplied by x squared plus 3. Then we begin by factorizing the denominator. So we have x squared plus 4 square root of 3 times x minus 15. So we need to factorize it by dividing it with x minus square root of 3. So we're going to perform a synthetic division here. So first let us list out all the coefficients of the quadratic polynomial in decreasing powers of x. So we have the coefficient of x squared, which is 1, then followed by the coefficient of x, which will be 4 root 3, and finally the constant value, which is negative 15. So we're going to divide it by square root of 3. So first thing first, we bring the value 1 right below and write it right below it. Then we're going to multiply 1 with square root of 3, so that gives us root 3, and we're going to write it below 4 root 3, and adding down the column, that gives us 5 root 3. Now we multiply 5 root 3 to the square root of 3, so that will be simply 5 times 3, which is 15. So we have a positive 15, and we write it below negative 15. Adding down the column gives us 0, meaning that the remainder is 0. So this can be now rewritten as x plus 5 root 3. So this is going to be one of the factor of x squared plus 4 root 3 x minus 15. So now we finally have the factors as x minus root 3, since this is one of the factor, times x plus 5 root 3. Now we're going to rewrite our rational function. So we have in the numerator x minus square root of 3 times x plus square root of 3 times x squared plus 3 divided by x minus square root of 3 multiplied to x plus 5 root 3. Now we see that there is a common factor, which is x minus root 3 in both the numerator and the denominator as specified here. So we can cancel it out. That leaves us with x plus square root of 3 multiplied to x squared plus 3 divided by x plus 5 root 3. So now we are going to find the limiting value when x approaches root 3. So let's write down the limit here. So we have x going to square root of 3, which will be equal to the reduced expression. So that gives us, now we're going to do a direct substitution, substituting the value of x into a simplified rational function. So we have square root of root 3 plus square root of 3 multiplied to square root of 3 squared, which will be 3. So we have 3 plus 3 divided by square root of 3 plus 5 root 3. Now root 3 plus root 3 is going to give us 2 root 3, and 3 plus 3 will be 3 divided by root 3 plus 5 root 3 will give us 6 root 3. Made a mistake here, so 3 plus 3 is going to give us 6. So 6 root 3 is common into both the numerator and the denominator, so that gets factored out, leaving us with a limiting value of 2.